All right. Well, good morning, ladies and gentlemen. Let's see, what is today? Today's 8/10, years 2020. So listen, boys and girls, this is for the Precalculus class. Um, Wish we had better software. I could make videos better, but so you're just going to have to watch this and listen to me for now. Check this out. This is a little bit of review. And so if this is something you don't need work on, then then you can just go to the Google Classroom and uh, try those problems right now. But if this is something you are having trouble with, then this is going to be the video for you. So check this out. Here's where we're going. Check this out. So what we're going to end up doing is we're going to end up graphing stuff that looks kind of like this. Okay? So this is going to be a function, right? And it's going to be something like, this one's going to be something like, I don't know, x cubed minus 2x squared plus 3x plus 2. Something like that. I don't know, I just made this up, right? So one of the things we're going to be doing is we're going to be finding these points right here. Those are called, of course, those are called X intercepts, right? Now, all of these points, like these, this is made up, right? This function doesn't match this graph. They're examples. But all of these points right here, like this one right here, they're all coordinates. And with these coordinates, y is always 0. So like this one right here could be like -5, 0. This one right here might be 1, 0. And this one right here might be something like 3, 0. But you see, for all of them, for all x-intercepts, the y-coordinate is always 0. Do you see? So the way we actually find these x-intercepts is we set the whole function equal to 0, and then we try to solve it. Right? That's going to be what we start this class with, is being able to solve something like this. Now this one I just made up off of the top of my head. It might not be solvable, but let me give you an example that would be. So let's say our function was this right here. Let's say x plus 5, x minus 1, and x minus 3. Do you see? Let's say I gave you that function right there and I asked you to find the x-intercepts. Yeah? To find the x-intercepts, the very first thing you're going to do, I'm not going to write this step out for you, I'm going to tell you, and you can pause the video and write it if you want. Your very first step that you're going to do is you're going to write a 0 for x, or sorry, for y, because this right here, f of x, that's the same thing as y, because y is a function of x, right? So make that equal to 0, right? And then what you do is you factor it. Well, this one's already factored, so that makes life easy, do you see? And then you take each factor, and you set each factor equal to 0, like we have here. So each of those factors is set equal to 0, and then what you got to do, you just solve those factors. So like you're just using inverse operations. These are really easy. Like this says what plus 5 is equal to 0. Well, -5 plus 5 is 0, right? But if you couldn't figure it out, you could just subtract 5 from both sides. 5 minus 5 is 0. X equals -5. This one, you could add 1. X equals 1. Or you could just read it. What minus 3, what number minus 3 is 0? Well, that's got to be 3. But if you couldn't think of it, you could add 3 to both sides. You see that makes 0. That makes 3. X equals 3. So your 3 x-intercepts are -5, 1, 3. That's how we're going to do this, right? Now this was easy because it was already factored. But from what I saw and what we talked about last week is this. You guys were having a little bit of trouble. Some of you were having a little trouble factoring something like this, right? So you were having trouble factoring something like that. And factoring means to break it apart into its smallest components. So let's say we had this as a function, right? And you'll see where this ties into what we just did in just a moment. Well, here, if you remember, a is the leading coefficient. The leading coefficient is the coefficient of that term with the highest exponent. Highest exponent is called degree. So here a equals 1. Excuse me. Here a equals 1, right? So when a equals 1, all you've got to do is figure out what numbers multiply to c and the same numbers that add to make b. So the numbers that multiply to 5 are 1 and 5, and that's it. Right? Now it's negative, so they have to be a different sign. So we're either going to have one of these situations right here. Right? we're going to have that, or we're going to have this. Now, if you already know this, then hey, you're doing great, no problem, right? But this is just review. I want to go slow for people that maybe forgot this. So look, one of these two is going to be the answer to this, if this is factorable, because there's only two numbers that multiply to 5, a pair of numbers, 1 and 5. Because it's negative, one of them has to be negative, because a negative times a positive is negative. It's the only way you can get it. So if you look at this right here, if we look at the outside and we look at the inside, this would be negative 5 plus 1. Well, that gives us a negative 4. We need a positive 4. This one gives us a 5x, right? And a negative 1x, and that makes 4x. These are x's, right? And so those are our answers. So x minus 1 times x plus 5 is this thing factored. So if we were finding the x-intercepts, you take it, set it equal to 0, you would take each factor and set each factor equal to 0. And you get x equals 1 and x equals negative 5. Do you see? All right, let's see here. We're going to do one more example, and then we'll get on with it, all right? So now let's say we had something like this, 2x plus 3 times x minus, 7, right? Now, the reason we're going to talk about this is because factoring is the opposite of multiplying. Factoring is the opposite of distributing. The way you multiply this, like if you were going to write the whole thing out, not using a shortcut, this means everything over here times everything over here. So it would be 2x times that. So that would be 2x times x minus 7, and then plus 3 times that. Do you see? So 2x times this, 2x times x minus 7, plus 3 times x minus 7. So this is like the longhand way of writing this out, and I'll show you where this comes together in just a second, okay? So we go ahead and distribute. That's going to be 2x squared, and then minus 14x, and then here, plus 3x, and then minus 21. Do you see? Negative times a positive is negative. So here's what we got. We actually have right here first, outer, inner, last. FOIL. You see? If you do first, you get 2x squared. You do outer, you get minus 14x, right? Outer. You get inner, you get plus 3x, and you get last, the last two, minus 21. That's where it comes from. Do you see? And then, with most of these quadratics, all you got to do, add the O and the I. We call that the OI. So that's 2x squared minus 11x minus 21. Boom, done. So, now here's where we're getting into trouble, right? Let's say we had this function right here. Let's say we had 2x cubed minus 11x squared minus 21x. And let's say that your job was to find the x-intercepts, right? So we got this wonderful thing right here. We're going to find the x-intercepts, okay? Well, to find the x-intercepts, first thing you got to do is you got to take the function, set it equal to 0, because this is y, remember, and all x-intercepts are some number for x and 0 for y. So we're going to take it, set it equal to 0, and we're going to factor it, right? Now, let's just go ahead and we'll take our time. Math is like dating. You don't want to hurry. You'll make a mistake and get embarrassed. Your friends will say, I told you so. Anyway, so we set it equal to 0. Now we're going to factor it. Now there's two steps to factoring this one. Do you see how each term has a common factor of x, x cubed, x squared, and x? We can take an x out. And then we've got 2x squared minus 11x minus 21. You see? Now we already know the factors of this because we just did it right here. But let's say we didn't, right? This is where it gets tricky because you see a is not 1. A is not 1. So here we have to see if we can factor this a little more, and we're going to have to be careful with that, right? All right, now before we do that, we have one factor, we have two factors. All right, let's go ahead and say, let's see if we can get this one done. So check this out. It's called guess and check. Pencils are good. I've been using a pen so it'll show up a little better, but check this out. I know for sure that the number here and the number here that multiply together to make that, you see? Like, we're trying to figure out, let's say we don't know what these numbers are, we just know it's going to look like this. This times this will be our leading term. So 2x times x is going to give us 2x squared. I know that for a fact. What I don't know is I don't know if this is going to be like I mean, I do because we just did it, but when you're factoring it and you don't know the answer, you have to figure out what number goes here and here. They're going to be factors of 21. So 21 could be 21 and 1, 3 and 7. That's it. That's all that multiplies to 21. So this could be a 21 and this could be a 1, like this. Or it could be a 1 and then a 21. And we don't know the signs. You see, that's negative. That means we don't know if this is a positive or that's a negative. So we're going to save those for the end. Or it could be a 3 and a 7. Or it could be a 7 and a 3. We don't really know. It's called guess and check. So check this out. That's what we're going to do. We're going to guess, right? Now, I already know what it is because we did it, right? But let's go ahead and let's say we guessed wrong. Let's say we thought this was a 3 and this was a 7. Watch, check this out. What we're going to do is we're going to check the OI, the outside and the inside. Do you see how the outside makes a 6x? The inside makes a 7x. Now they're different. It's negative, so we're going to subtract. That means, I don't know if it's going to be a plus or a minus, but it would just make 1, and we need it to be 11. So that doesn't work. So the next thing you do, if that didn't work, all you got to do is you switch them. We put the 3 here and the 7 there. Now if this doesn't work, then we would try the 21 and the 1. See if that would give us what we need, right? All right. So here we have on the outside we have a 14x, on the inside we have a 3x. Remember, we're subtracting. If this was a plus, these would be added. So that makes 11x. So those are my right numbers because I need an 11x. Now here's the tricky part. I need to figure out which one of these is positive and which one of these is negative. You see, I need an 11 to be a negative. That means this number has to be negative because this was positive, this would be negative. That would give us a plus 11. We need it to be a positive. We need it to be a negative, so this is positive right here. So the way we get the 3x is these two, so that's a plus and that's a minus. Then we take, right? So now we take each of these three terms, 3 factors, 1, 2, 3 factors. We set each factor equal to 0. Right? And we solve each of them. This one's already solved, so we already know we have 0, 0. Done, boom, done. This one's going to be 2 steps. We first have to subtract 3 from each side. 2x equals negative 3, divide by 2, divide by 2. X equals negative 3 over 2. So we have also negative 3 over 2, comma 0. Last one, just add 7 to both sides, easy peasy lemon squeezy. So we have 7, comma 0. All right, so that is supposed to be review. I know that for some of you that was like really, really fast. You're going to have to pause it, or go back and watch it. I will put some links in Google Classroom for you. I will also upload some practice problems there. So what we're going to do today is we are actually going to work on this, and then we'll go over it tomorrow. So we're going to meet tomorrow morning to go over this. All right? So anyway, yeah, we'll get started.